So we have a complex number. How do we multiply them together? Well, if two complex numbers look like this, I think it's pretty obvious. We have to expand the brackets. So for this one, we have to expand these two. So this will be 5, 15 plus 20i. And then on the bottom, we have plus 3i plus 4i squared. Okay? And so what we're left with an answer is 15 plus 23i plus 4i squared, right? Well, what's a fundamental principle of this topic? I squared is equal to minus 1, which means that this is equal to minus 4. And so what we're actually left with is an answer of 15 minus 4, 11, plus 23i. Let's look at this next example. We got 6 times 7, 42. 7 times 2, which is 12i. 6 times 2, excuse me. 3 times 7, 21i. And then 3i times 2i will just be minus 6. Why? Because I squared is equal to minus 1. And so now what we do is collect the like terms. 42 minus 6 is going to be 36. 21 plus 12, that's equal to 33. And so what we're left with is 36 plus 33i. Now for the third example, again, same principle. 5 times 1 is 5. 5 times 5 is 25i. 2 times 1 is negative 2i. And then 2i plus 5i is going to be minus 10i squared. But remember, I squared is equal to minus 1. So this is the same as, we can just say that this is 23i, because of course it is. But 10 minus 10i squared is equal to 10, isn't it? So this is the same as 10 plus 5, 15 plus 23i. And so those are your final answers for those 3 questions. Does that make sense? Well, make sure you subscribe so you never miss a video like it. Now let's look at these examples. Write each of the following in its simplest form. So here we have I to the power of 6. I to the power of 6 is the same as I squared cubed, isn't it? So all we need to do is remember that I squared is equal to minus 1, and then cube that, and so we get I to the power of 6 is equal to minus 1. Okay? All it is, it's the same concept. Same concept. Exact same concept is this. 3i to the power of 4. 3i to the power of 4 is the same as 3 to the power of 4 times I to the power of 4, which is equal to 81, times I squared to the power of 4. Which is I squared squared, which is the same as minus 1 times minus 1, which is equal to just 81. Now let's look at part C. Part C, we have I to the power of 5 plus I, right? I to the power of 5 is the same as I squared times I squared squared plus I squared squared is the same as 1, so this is the same as I plus I, which is 2i. Okay? And finally, let's look at part D. For part D, we have 4i cubed minus just 4i cubed. 4i all cubed is the same as 4 cubed times I cubed, which is the same as 64 times I squared times I, which is the same as minus 64I. Why? Because I squared is minus 1. Now let's look at 4I cubed. 4 times I cubed is the same as, well, we know that I cubed is equal to minus I. So this is the same as minus 4I. So minus 64 minus minus 4I is the same as minus 60I. And so that should be your final answer for part D. Is this still not making any sense? Well, you can join my Discord server to ask me any questions you like. But for those who do find this simple and make it make sense, we know that I squared is equal to minus 1. So what is I to the power of 5, I to the power of 6, I to the power of 7, and I to the power of 8? Let's work with, what did we say? That I to the 4 is just equal to 1. Why? Because it's I squared squared. So we can work from there. I to the 5 will just be I to the 6 will just be minus 1. I to the 7 is minus I. And I to the 8 is 1 again. Okay. How about we continue that trend to I to the 100, I to the 253, and I to the 301. So first let's look at I to the 100. I to the 100 is the same as I squared to the power of 50, isn't it? Do we want to times this 50 times? We can do if we want, but we can do better. We can do better. So what we can do is we can say that this is also the same as I to the 4 times, or all to the power of 25. And as we know I to the 4 is equal to 1 to the power of 25, which is just going to be 1. Okay? So all we're doing is using laws of indices, and I squared is equal to minus 1. Let's use that same principle here. I to the 253. What numbers go into 253, do you think? Exactly, 252. Well, this is the same as, what I mean is the same as I times I to the power of 252. So again, we're just manipulating the laws of indices again. Poor wording, but that's what we're doing. I to the 252 is the same as I to the 4, right? All to the power of 63. Yeah? And because we have I to the 4, right? We know that this is all equal to 1. So I to the 253 has to be equal to I. And finally, I to the 301. This one's pretty straightforward. I to the 301 is the same as I to the 300 times I. And we know that I to the 300 can be written as I to the power of 4 times 70, to the power of 75. And because we have I to the power of 4, this will just be 1. So I to the 301 is equal to I. So again, all it is laws of indices. Thank you for watching. Please drop me an email if you guys want to get tutored to pass your exams. Keep on learning as you have no idea what you're capable of doing.